Right. So, yeah, we are live on YouTube, and yeah, so I will just make the announcement and then we can start. So, welcome everyone again. Today is the third day of FIRE 2020, and we have our first invited talk for the day by Professor Paul Clough, and the talk is on algorithmic bias. What is it? Why does it matter? And what's being done about it? Over to you, Professor Clough.
Great, thank you very much, and thank you very much for inviting me to come and to speak at FIRE. It's brilliant to be here, and so as mentioned, what I'm going to talk about today is the topic around algorithmic bias. And in particular, what I wanted to do is focus on and introduce a study that myself and some colleagues did a couple of years back now, looking at bias within image search. So I thought I'd use that as an example of seeing biases within a search engine and search engine results. The kind of final bit I'll have a think about and we can talk about is then what can be done about this, and then summary at the end. So I guess you probably know and very well aware that algorithms, data is heavily used in algorithmic decision making or data-driven decision making. Algorithms can support, decision making through various ways. For example, prioritizing, ranking, making predictions, finding patterns, associations, filtering. And predictive models that are built are used for many different purposes. So that includes, for example, credit scoring, automated CV screening, profiling by police, personalization, recommendations, and so on. Well, I guess over time, we've seen, certainly in the media, and we're seeing more in the kind of academic community now, an awareness that algorithms are certainly by no means neutral or objective. So although when people are building predictive models, typically the process is fair, it's well-intentioned, sometimes the outputs are not entirely fair and can actually discriminate. And so it's often a term that we refer to as bias or algorithmic bias. And bias refers to when an output is prejudice for or against one person or a group of people, considered in a way to be unfair. And that could be bias around things like age, gender, could be around race, and so on. And the problem is that within kind of data-driven algorithmic decision-making, the bias kind of works its way through. So we know that there are often biases inherent and hidden within data. The data is fed and used by an algorithm to build a model. And of course, that bias just works its way through the system to eventually being present on the output. Now, of course, the algorithm itself is controlled by humans, and humans themselves also are biased and have many different types of unconscious bias. And therefore, what we end up with is a system by which you can end up having outputs that discriminate. You might have seen this article in the New Scientist, which gives 5 different examples of how AI has shown to prejudice. For example, Google in their online advertising system at one point was showing high-income jobs to men much more than to women. There's also been problems with automatic translation being biased, particularly around kind of gender biases as well. There's been biases in policing, in the legal system, the law courts. Probably the most famous example there is the study that was done of the compass system used in the US. And there are many, many other examples of bias that we see, certainly within the media. For those of us working in NLP as well and information retrieval, there's also been various studies and work done to also show the type of biases that can be present in natural language processing and IR tools as well. So there's a very interesting study by the Oxford Insights team, which looked at racial biases within NLP systems. And often these biases are basically inbuilt into the data that we're now using, vast amounts of data from many different NLP tasks, be it sentiment analysis, natural language generation, and so on. Now, although there are many biases and the biases have serious real world effects, it's not all bad news, and we shouldn't think of it as all bad news, because what's happened is that the attention given to algorithmic bias, I think, has kind of helped raise people's awareness that all processes that are controlled and governed by humans are in some respect biased. There's a very good book, if you want to find out more about algorithmic bias, called Understand, Manage and Prevent Algorithmic Bias by Tobias Bauer. And there's a great quote where he says that it's a myth to think that algorithms are objective. They are not neutral. They are subject to human biases. But he says it's also a myth to think that human processes are not subject to biases on par with algorithms. So I think it's been quite a healthy focus, if you like, on algorithms and algorithmic bias that has also led to people trying to question human biases and human processes and decision-making processes as well. But what I want to do is kind of give you more of a kind of concrete real-life example of bias, and a study where we were looking at gender bias in search engines. So this is based upon a study that I did with two colleagues of mine, Jana Otterbacher from the Open University of Cyprus and Joe Bates from the Information School at the University of Sheffield. And this was a paper that we wrote for CHI back in 2017. And we were very interested here in looking at image search, and particularly the results of image search and whether there are any obvious biases. Now, you know, we know that bias in search is not a new thing, and people have kind of studied this for a while. So there was that kind of article, it's a while back now, probably a couple of years ago at least, where Google was claimed to favour, the search results favour Democrats as opposed to Republicans. And there have been other studies that have been done as well to kind of investigate and look at bias in search engines. But I guess the kind of focus for us was actually we built our work on a prior publication at CHI back in 2015, where Matthew Kay and colleagues had looked at gender stereotypes, but in the context of work and professions and occupations. And in their study, they'd seen that there were very kind of obvious stereotypes that exist in the real world that were also found to be present within image search. And so, for example, here you can see this is a search on Bing for nurse. And what we see back in terms of the results are probably quite stereotypically true. But what we see are many of the results are for females. But it's not just that. Many of the results are for maybe middle-class females of a white background. So here what we're seeing is a kind of portrayal, a stereotypical view on who is a nurse, as seen through the eyes of Bing images in this case. And so we were kind of very interested in this study, and we were interested to see actually, you know, could we extend this? Just to say, in that previous study as well, it was quite interesting that as you looked at Bing, so even when you looked at the categories, so one of the categories actually on the image results was for male nurse. So if you had a look at that, what you would then see is, you know, examples of male nurses. But actually, what you often saw was something else that comes through in the stereotype literature, was the notion of a kind of backlash effect here. So quite a lot of the images you see are kind of funny, or they're joking images. They're not kind of you know, sort of true images of male nurses. And this is often what you'd call backlash. So somebody who's kind of unusual, standing out from the group. So what we wanted to do was kind of expand this a little bit beyond kind of beyond occupation to kind of personality traits. So more generally than just looking at occupation, could we see whether Bing images, in this case, exhibited any gender stereotypes? So for example, if we put in the term intelligent person, you know, who does Bing say an intelligent person is? And we can see here it's wholly men. That's okay. So there's a gender stereotypical view going on here. And so what we wanted to do is kind of explore this in a little bit more detail. You can also see the same type of thing as well if we search, for example, for shy person. So in this case, the majority of the people returned, or the pictures returned, are images of females. So what we wanted to do then is carry out a study where we could have a look at this in a little bit more detail. So to be able to do this, though, we needed a kind of framework to work against. And so what we did is we used the social psychology framework around stereotypes. So you probably heard of the Big Five instrument that's used to capture personality traits. Well, there's something similar that is used when people study in social sciences stereotypes, so how we view other people. And often our perceptions of others are based upon two dimensions. So the two dimensions are typically agency or competence and warmth or communality. And so agency says whether we perceive somebody as being capable of achieving their goals. Warmth is about whether or not we perceive somebody as being a threat towards us. And so when you're thinking about how you might quantify and capture stereotypes, we can actually use the big two here to kind of capture basically the notion of stereotypes. So typically what happens is that the stereotypical view of a woman would be low agency and high warmth. The stereotypical view of a man would be high agency and low warmth. And so we can use this framework to help us in terms of how we might investigate whether we see any stereotypical gender views percolating through to Bing images. The particular method that we used for this was one that's been tried and tested a lot in social psychology, which was called the trait objective checklist method. And so here, this is a kind of a mechanism, or it's a kind of a method that's used, which consists of 68 different traits that have been developed over many years by psychologists for understanding how we can measure social stereotypes. And basically, it consists of a number of adjectives. These adjectives are used to kind of put you on those two dimensions of warmth and agency. So the types of adjectives that you have are, for example, would include things like able, affectionate, reserved, critical, tolerant, trustworthy, and so on. And so what we wanted to do in this study was basically use these to form queries for people. So in our case, what we did was simply formed queries that would be the adjective followed by the term person. So for example, conscientious person. And the aim then was to see what types of results did you get back, and would this match what the literature, the psychology literature tells us about how people view men and women in the real world. So the aim is saying, so what we're trying to achieve here is, do you see that kind of same views making its way through the kind of the digital world? So what we did was construct a series of queries on Bing images. We used Bing images because it was the most available to us. We used the API, the search API, and we also tried to look across different markets. So we looked across UK, US, India, and I think that one is China. And so the questions that we had in the paper that we wrote were three different questions. One of them was, first of all, a kind of baseline representation bias question. So if you just search for person within Bing images, which genders are depicted? So are the results kind of focus more on men or on women? You might expect that ideally there'd be perhaps 50-50 representation. The second question was around stereotype content and strength. So we were interested in which character traits are most associated with which genders, and how might they map onto kind of what the literature tells us. We also had a look at backlash effects as well. So how stereotype incongruent individuals are depicted. So if you don't fit in with the norm, how are those types of people depicted? I won't talk about that part of the study in today's talk. I'll just focus on those first two questions. Okay, so how do we go about this? So the aim is that you type in a query like shy person to Bing images. And what we need to do then is label each of the images that come back as, do they depict pictures of men or women, or maybe we don't know. I guess the first question then is before we start to try and automate this, the first question is, well, how hard would that be for a human to do? So what we did is set up an experiment on Crowdflower, a crowdsourcing site, where we took 1,000 person images, so person images from querying Bing images from the UK market. And we set up a crowdsourcing experiment where we had 3 annotators per image. And what we asked the annotators was, first of all, is the image a photo, a sketch, or some other type? The second thing we asked them was, does the image depict only women or girls, only men or boys, a mixed gender group, gender ambiguous persons, or no persons? And actually, this was a relatively successful task. So we could see that there were relatively good levels of agreement for judging whether, first of all, is the image a photo, a sketch, or other. The other one obviously is a bit trickier to work out. There's less agreement on there, but there were a few less cases. We can see also that the results generally are for photos. So that's probably the thing to focus on. In terms of then classifying gender, what we tend to find here is that also there is a generally good agreement. We also tended to see that the precision was generally good, the recall was lower. What we also found was that for sketches, there were lots and lots of kind of unknowns. So this kind of led us to think, well, actually the sketches are not particularly useful for this study. So let's just focus on photos, which hopefully we can automatically identify. Okay, so in terms of then how we might automate this, so we don't really want to do this manually because the amount of data that we're trying to look at is quite a lot. So what we decided to do was use an automated gender recognition tool, so a general image recognition tool called Clarify. And Clarify provides an API that you can use. And the API is good. You can feed in an image and it gives you back a set of terms describing that image. In terms of the tool itself, the coverage was pretty good. So of the images that were returned in that 1,000 sample, you know, it could certainly work with 95% of those. So it's not too bad. So then you feed in an image, out of it you get 20 different tags or words. What we then did was to try and categorize those tags to work out whether they were references to male or female. We used the LIWC dictionary, Linguistic Inquiry and Word Count. And so what we did here was we're able to basically then work out and use this to say, well, man and guy are male references. So we just look up in the dictionary for that. We're able to then simply just look at the proportion of male references versus female references to try and then, you know, establish or infer whether the image is of a male or a female. Okay, so just to run through again that approach. So we gathered the images. So we typed in the query for person on its own, and then query plus one of the adjectives and the term person. So there are 68 different character traits plus the term person. So it's 69 different queries. And then we did that across we gathered the top 1,000 images for each of those queries, and we did that across the 4 different markets. So in total, we had about 276,000 images as our kind of data set. We then analyzed the images. So we used Clarify for image recognition to basically identify so tags or label the images. We filtered out any photos that had with the portrait tag, because those typically, we included those, so it's typically better represented kind of people. And then what we did was use the LIWC to try and infer gender based upon analyzing those tags. So just looking at, as a test data set, those 1,000 images which were manually categorized. In terms of recognizing photos, actually, you know, the performance is relatively good. In terms of then recognizing gender, precision generally is pretty high. The recall is lower, which would sort of indicate that we're missing photos that are picked up by the human annotators. But overall, the precision is high, which is kind of what we wanted. So the results are okay on this, which led us to think, okay, hopefully the results on the 276,000 images would be okay. So in terms of then what were the results and looking at the kind of research questions that we asked, of course, there's a lot more detail in the paper itself. So if you want to know more about what we discovered, then please do have a look at the article. But first of all, let's just have a look at, in the first research question, it was about, in terms of being images, who represents a person? So if you just type in the query for person, what type of result do you get back in terms of gender? Male images, female images. And this is what we get. So this is looking at the different markets for the first top 100 images, 200 images, 500 and 1000. And if we just maybe have a look at the top 100 images, because a lot of people might only look at that particular set of search results, the results are fairly striking. So the dark bar are images of males. The lighter grey or the medium grey are images of women. The other bar represents other. So you can see that predominantly, particularly in the higher ranks, the results for a person, so who represents a person, are predominantly male. So there's a clear preference and stereotypical kind of perspective or view being pushed through. So the view here is very much of male view. And we can see that that also kind of is true as we work down the list. As we go down, things do even out a little bit more, but there's still underrepresentation from women. So that was the first question that we looked at. The second question we looked at was more around seeing which of the traits that we have, those 68 adjectives, typically group together. And do they group together or cluster together in a way that would be similar to how the kind of stereotype literature in psychology would normally expect things to work? Again, that would give perhaps more support towards the image result search being gender biased. So what we did for this was literally just take for each of the traits, for example, sort of competent. We then use k-means clustering on this, and so what we did is we use each of the kind of, if you like, the kind of features fed in would be the trait together with the proportion of images that were depicting male, proportion of images predicting female, proportion of images predicting other or neutral. And then we run the clustering, and this is kind of what we get out of it. And we can see that actually it generally tends to actually associate quite well and with prior literature. So for example, we see that this green here, these are the traits that were typically most commonly being portrayed for image or associating with pictures of women. So warm, emotional, sensitive, shy, and so on. The psychology literature in stereotypes would tell us that these are the types of kind of traits, if you like, that are commonly associated with women. The traits most commonly associated with men, so industrious, decisive, ambitious, lazy, boastful, and intelligent, competent. Again, that does match and relate strongly to the prior literature. And then the traits then kind of associated with neutral images, so vulnerable, understanding, able, and so on. It was very striking that the groups, the clusters, were very kind of representative and aligned well with existing stereotype literature. If we looked at this across the regions as well, remember we were looking at 4 different regions, there didn't seem to be huge differences across the regions, and in fact the clusters were fairly consistent across the regions. So there was a consistent gendering of the traits. So for men and boys, the consistent kind of traits were ambitious, boastful, competent, and so on. For women and girls, it was emotional, expressive, sensitive, shy, warm, and so on. Again, these do relate and match the literature very closely. So what does this tell us, and what do we learn? I think one thing that we need to be clear on is that the Bing algorithm itself is not gender biased. So the developers would not have gone out to make the algorithm gender biased. However, what we do see is that because the algorithm is based upon the data that's fed in and the interactions that are undertaken with the search ecosystem, we do see that the Bing image results do perpetuate gendered perceptions of personhood. So what we experience within the real world about gender stereotypes, we do see present in this case on Bing images. And this backs up, and it does confirm many other previous studies as well, that real life is often mimicked and mirrored in the digital world. So what can be done about this? I mean, bias is a hot topic, and looking at algorithmic bias is a hot topic. And there are many kind of great projects, many good research and kind of commercial people working on this. So I guess one of the things that we can do is think about fairness, we can think about bias, we can think about discrimination as we design our algorithmic decision-making tools, as we carry out our machine learning. So, for example, that can go right the way from the problem formulation. We can think about, is this a ethical problem for us to be applying machine learning? Then through to data and data set construction, where we might want to think about, for example, equal representation across, for example, protected groups, which might be disability, gender, race, and so on. And we might, for example, want to balance the data sets with respect to those groups. We might want to look at whether the labels that are used would reinforce any of those stereotypical views or biased views. Then it might be that we want to strive for equity through the algorithm selection and the training, and then through to things like the testing as well. So we might want to make use of things like explainable AI methods to be able to understand how has the algorithm reached the output. We might also want to use debiasing methods and so on to reduce and mitigate the effects of kind of noisy or biased data. Then you might want to think about deployment and feedback as well. And so those feedback loops, are those reinforcing kind of equity or bias, or are they helping to reduce and mitigate? Of course, there are many other things you could do. Some of the things involve technical solutions. And there are many tools now available to identify data and algorithmic bias. That includes, for example, the Fairness 360 toolkit from IBM. There's the Google What If tool and many other tools as well. And these tools help you in terms of reducing discrimination. There's been a lot of work on measuring discrimination within the data mining community. And they here the terms discrimination discovery, discrimination prevention are commonly used, and there are plenty of methods around tackling those issues. There's also the area around explainable AI, and there's also tools for algorithmic auditing as well. I guess the other thing we can do is around education, so making people, particularly the general public, aware that there may be biases within the systems that they are using. And so, for example, helping develop algorithmic and data literacy, helping people understand that algorithms are not neutral and objective, they are biased, along with many other processes within which we interact. And it's been, fantastic to see a real surge of interest, certainly within the academic community. There's conferences, for example, FAT and so on, that are tackling these issues head on. There's also been a number of research projects that are tackling, so the No Bias project in the UK. There's also this project that I've highlighted here called CICAT, the Cyprus Centre for Algorithmic Transparency. And this is looking to educate people, mainly focused in Cyprus, but also around the world, about the problems around bias, and collaborate and bring people together to help tackle and discuss these issues. There's also a lot of initiatives going on within industry. So, for example, in Microsoft, they now have the FATE group, the Fairness, Accountability, Transparency and Ethics in AI group. And most other companies now are setting up and creating these types of groups. I guess the other way of tackling this would be around governance and transparency. So having in place clear governance procedures and algorithm accountability. And you might think, well, whose role is it? Is it the chief data officer's role, or is it somebody else's role? I also mentioned before about developing an algorithmic audit trail. So documenting and making very clear how data is being collected, how data is used, for what purposes. Also having clear ethics and governance frameworks, for example, making sure that you get consent for using people's data and so on. And within the UK, there's been a number of initiatives, and certainly within Europe as well, around setting up governance and transparency frameworks. And it started to become mandatory for many industries and organizations as well. Okay, to summarize then, decision-making is increasingly data-driven, and there are many benefits of using data and algorithms for making decisions. Algorithms are commonly employed to support, often and automate decisions and processes. However, algorithms are not neutral or objective. We have to understand that algorithms, like humans, introduce biases. And one area of concern at the moment is this notion of algorithmic bias. Hopefully in the example of image search, we've seen that algorithms and digital systems can perpetuate the bias. So that means that the bias that we see in the real world can make its way through into the digital world. There are many solutions to this, that it could include technical solutions, educational solutions, governance solutions, and so on. But I guess the key thing here to remember is that we can only expose, measure, and try to reduce bias. You're never going to be able to completely eradicate it, partly because algorithms are fed by human processes and data. There's many resources that you could look at if you wanted to find out a bit more, and I've just highlighted a couple here. So one of them is the book by Cathy O'Neill. It's a really, really good, interesting read called Weapons of Math Destruction. And this highlights a number of areas where stats and maths and AI is being used, and the results are biased outputs. The book by Tobias Bauer is a really excellent hands-on book called Understand, Manage and Prevent Algorithmic Bias. And it's really helpful, particularly if you're working in business, as it gives you some very much hands-on advice and guidance. In terms of the way that search results are biased and the effect that they can have on people, then probably the Algorithms of Oppression book, how search engines can reinforce racism, by Sophia Noble is an excellent book. And I've also written a short blog article as well on the website Peak Indicators that kind of mirrors some of the stuff that we've talked about in the session today. Brilliant. Well, thank you very much for listening, and happy to take any questions now if you have them.
Yes, I have a question.
Right.
Hello, Paul. It was a wonderful talk.
Thank you. Thank you.
Yeah. So my question is, I mean, not only about bias in basically image-based searches, but I'm talking about, I mean, the biases which, I mean, the bias that is present in the, I mean, in the data set that can lead to serious consequences. For example, I read a paper when, I mean, where, I mean, there was some reference to an automatic job recommendation system where only the whites or only the males were basically preferred over basically the others. And there can be situations when I mean, suppose when you do a search on a search engine, maybe due to inherent system, I mean, inherent bias in the data, when you, I mean, do a search, possibly a company or a product that is owned by a female is not shown by the system. That can lead to, I mean, serious loss of I mean, basically money and job and all these things. So, I mean, basically, I mean, the study which you are doing is, I mean, showing the bias which is already present. I mean, which basically, I mean, reinforces the fact which we already know. But here, I mean, no one is at the peril of, I mean, losing something, I mean, really serious in terms of, I mean, finance. So what can we do, I mean, can be done to, I mean, mitigate this, in your opinion? Yeah,
great question. So first of all, let me just say one thing about the, I guess, the impact or significance of what we were looking at. You might think that it doesn't really make any difference, and arguably maybe it's not life-threatening. But in the UK, search engines are used in primary schools for teaching children. And therefore, if you're in a class and a child is searching for doctor, and it's a girl, and all she sees are pictures of white men of a certain kind of class, maybe it leads her to think that she can't be a doctor. So we have to also be aware that there are quite a lot of implications that we might not understand about the results of the search engine, even though it might not necessarily be life-threatening. In terms of some of the things you highlighted, there's been a number of studies that have shown, for example, that data sets that are used for image search systems are basically biased, and they are not representative, all the groups fairly. So probably you're aware of the Gender Shades project. So, so the woman who's recently been fired from Google, she was a part of that project, and she did a lot of work looking at racial biases within image search systems. And they clearly showed that image search systems are racially biased. These are commercial systems. Therefore, you know, the accuracy on men, white men, was far better than, you know, sort of maybe Asian women. And again, you might think, so what? Well, imagine that we have a self-driving car that is based upon that data that's been trained. The self-driving car would then potentially miss a woman more than they would miss a man and potentially hit them. Therefore, the accident rates for women are higher than for men. So I think what's really striking is that the community now is really investigating quite seriously the problems with some of the data sets we commonly use, together with the implications for this. And you're probably well aware, as I don't know if you're aware, but there's been quite a few studies also done on things like GPT, I'll get it right, GTE 2 and 3 as well, where the natural language generation system, which is just trained on loads of data from across the internet. And if you look at some of the comments and some of the language that is generated, it is actually pretty horrific in terms of how it, you know, kind of marginalizes men, women, people from different race.
Yeah.
So it's a real issue, and it's something that many researchers are tackling. We are one of many, many people in the big companies and industry are, you know, are taking this seriously as well, particularly with public and private sectors as well. So it's an issue, and it's one that people are seriously looking at. Really
so I mean, do you think something can be done along the lines of automatically suggesting that, I mean, some laws can be created in order to prevent something? I mean, prevent a search engine from, I mean, doing something or against something. So can a system automatically suggest some, I mean, reforms to the company, I mean, for the good of the company, and also to the government to basically look into these? I mean, so you see, there is a serious, I mean, imbalance in the data. So you should, I mean, do something about it. Otherwise, some people can take a legal action against, I mean, something which is existing.
Yeah, so I think there are a number of tools. I think I mentioned a couple of them that could help. I think, however, this has to be part of a human process, which is a part of regulating the AI and governing the AI. So we shouldn't just assume that the algorithm can kind of self-govern in some way. And many of the organizations, I work with an SME, data and analytics company in the UK, and many of our clients are nervous about using AI within the business because of the problem with, you know, kind of like algorithmic bias. However, they fully understand that they actually do need to document and audit their processes. And actually, there's quite a call in the UK for processes to be transparent. So I think in some respect, the tools can help kind of govern, and regulate, but actually this should be bigger. This should be a government, and it should be the world's issue around trying to govern AI. It's bigger than a company, it's bigger than one country. So we need to pull together on this, I think.
True. Okay, thank you very much.
No, thank you. Thank you.
Hello.
Hi, hello.
Yeah, Paolo here from Valencia. Hi, Paul. It's great talk. I was looking forward to listen to your keynotes. I knew by Jana Otterbarker from the Open University of Cyprus that you are very much into this topic recently. So great. And yeah, my question is, okay, FIRE is especially an evaluation forum. So I wonder if you know, I don't know about any, but maybe you know more for sure. I wonder if you know about some shared task on algorithmic bias, or I mean, how a task could be thought in order to address this problem, and somehow to help the research community to focus also from this perspective to address this problem. Thanks.
Yeah, no, thank you, Paolo. Great to see you again. I think there are shared tasks. Unfortunately, I can't think of any at the moment. but I certainly know like the EM NLP communities and so on, NACL communities and so on, ACL have been running kind of tasks. And I know there's been a lot of focus on looking at some of the existing data sets that we commonly use, both in NLP and also for kind of image processing as well. So for example, there's been work on looking at ImageNet, you know, that's commonly used for training image recognition tools, for how biased, you know, the data set would be in terms of gender and so on. So I think there are a number of initiatives, and there are test data sets and benchmarks that you could use to kind of evaluate the tools. But I think it's quite difficult because the notions of bias and fairness are very complex. And so how do you actually define what's fair or not, or how do you define what would be biased or not? Because actually part of the problem with, if you're developing a data set, is that you've got to label it. Well, if that's people labeling it, well, people are biased. So how do you mitigate that? So it might be that you have to have multiple annotators do voting and all the rest of it. But yeah, I think it's just hard. I think it's quite hard. But I guess the clear thing is that we know bias when we can often recognize it when we see it. I think it's a lot harder to kind of verbalize it and develop it into a problem that you can then sort of use as part of a shared task. So I think there are definitely going to be benchmarks out there, and I don't know if anybody else on the call knows of any benchmarks that are available.
Thank you.
Thanks, Paolo.
I have a question, Paul.
Hello.
Yeah. In case of even recommendation systems, normally the recommendations are done based on the behavior of the user. So if there is bias in the behavior of the user itself, then how can we manage the recommendations to be balanced?
Gosh, that's a very, very, very good question. How could you make them balance? So I think again, what's quite important when you're considering these types of topics is to start by considering the whole notion of kind of fairness and bias, and what do you mean by balance? So from your perspective, what would a fair or balanced recommendation look like? So, you know, it might be that there's some measure of kind of sort of the norm, if you like, that you could give, and you could look for kind of deviation from the norm. But I think it's quite challenging because what's biased to you might not be biased to me. And therefore, to kind of, certainly in the case of things like, you know, personalization and recommender systems, I think it's quite hard to kind of establish, you know, how you might kind of measure this and how you might mitigate it. So in our case, in the image search, what we did was we drew upon the kind of psychology literature to help inform, if you like, the notions of kind of bias and fairness and stereotype views. So I think you'd have to start by understanding what are you looking for? What does it mean to have a kind of a non-biased or a fair kind of outcome? And how would you then kind of, you know, sort of, you know, build that into your recommendations? There are certainly been many studies that have shown, for example, things like, you know, the autocomplete on Google. There were times when it would give you very biased results and quite horrible results in some cases. And that's been true of, you know, many other systems, and companies like Google have been, you know, very quick to react to that. But again, I think it's hard because what is horrible and, you know, unfair for one person might not be the same for somebody else. Just on the case of recommendations, though, just to give you an insight on how impactful those can be. There was a very sad case in the UK about a year ago now of a young girl. She was only about maybe 11 years old, called Molly Russell, and she was using social media. And of course, we see, you know, there's the recommendations and the effect of kind of recommendations, certainly within social media. And it's a very tragic case because she got quite depressed and she started looking at pictures around self-harm. And the recommender system, you know, was doing its job. And what it said is that, you know, people, you know, who have, or you are looking at this self-harm, you know, you may also be interested in this. And the system started recommending other pictures, and tragically, she took her own life. You know, and it related to me because I have a teenage daughter as well. And, you know, the developers of the system, you would have tested it on the accuracy and it would have been brilliant. You would have never have dreamed that that could have been the consequence or the output, you know, the outcome of your recommender system. And I think this is some of the problem, that we have a tool that you build in a lab and you're optimizing, you know, your objective function, high accuracy, performance, or whatever. But it can be completely used in a very different way in the real world. So how you would balance up the kind of maximizing accuracy versus fairness and so on. Again, there's lots of researchers who are trying to look at this, because the most accurate algorithm isn't always the most fair. But it's a real complex issue, but one which has very significant human impact as well. So thanks for that. That's a really good question. I don't know if I answered that very well, but thank you for that. It's a good question.
Thank you.
I don't know if there isn't anybody else. Maybe I would like to ask another question. Otherwise, I will prefer to give the floor to someone else. Just let me know. Well, anyway, is following the keynote a colleague here who is actually a social psychologist, and so I'm sure that. I mean, you'll explain everything in detail in the paper. Actually, I will ask you for the reference later, or maybe you can write in the chat so everybody will be able to access to the paper. But the question is about the adjectives. So how I'm trying to translate it on the fly from Spanish. How did you associate the adjectives? If they were in the text themselves, so in the captions of the pictures, or if the annotators basically gave these adjectives annotating the picture. Thank you.
Great, thanks, Paolo. So the adjectives are only used to generate the queries. And the adjectives come from, you know, many years of social psychology research where they've come up with these adjectives as being highly associated with those two dimensions in terms of stereotype and gender stereotypes. So that was our approach, to make use of the existing literature, the psychology literature that provided us with those adjectives, which we then used to formulate the queries. So we know, for example, that emotional is something that's highly kind of related to females. Therefore, you know, if you type emotional person, you know, what we wanted to do is the literature would say that typically you get pictures of women. And so what we were seeking to do was see whether that's true in the kind of digital world as well, which you potentially would expect it to be true. In terms of then actually doing the analysis on the images, we only used images, so we didn't use any associated text. And that's why we made use of the Clarify image recognition tool, which translated for us from image into the tags or the labels. So we then did our analysis only on those labels, where we were using the LIWC to try and infer whether the image through those tags was an image of a man or of a woman. And so in the paper, we have some kind of details on how effectively that worked. So that's the approach that we took. Now, in terms of an issue there, and I'm surprised somebody hasn't raised this as an issue, but I'm going to raise it because it was a problem with the study. And I think this is why you have to just think carefully about how you interpret the results that you get. We already know that image recognition tools are already themselves biased because of the data that they've been trained on. Therefore, surely you would ask that the image recognition tool that we were using in our study to work out whether it was an image of a man or woman is going to bring its own biases into that labeling. And the problem is, yes, it does. And that would also be true if we had human labelers as well. But it's problematic in the sense that we had to use the automated tool because of the volume of data that we had. But this is one of the issues when you're trying to kind of analyze and kind of unpick this type of area, because you're trying to study bias, but yet we're biased as researchers. The tools we're using are biased, the data's biased, everything's biased. And it actually becomes quite a challenge to, if you like, work out the truth from the noise in that. So yeah, I don't know if that answered your question, Paolo, but yeah, that's how we were using the different
thank you very much. Very interesting. We'll read carefully your paper. Thanks.
Yeah, so just to say that Jana has carried on and done some other really interesting work around the kind of the notion of bias. So do have a look at her publication. She's done a lot of work around that, not just gender, but also racial bias as well.
Yeah, thanks.
Thank you.
Right. Any more questions from the audience? Thank you. Yeah, thank you, Professor Clow. It was a really insightful talk and very relevant to the current situation that we are going through due to this.
Thank you very much.
Yeah,
Thank you.
thank you. Thank you so much. All right. So moving ahead. Okay, so next we have the HASOC Dravidian code mix track presentations, and I think Bharti is going to chair the session.
Hi.
Yeah. Hi, Bharti. Yeah.
Thanks, Sudhita. So this is a hate speech detection in the Dravidian language code mix sessions. So our first presenter is Siva Sai, and his paper title is Multilingual Offensive Speech Detection in Code Mixed and Romanized Text.
Good evening, everyone. Am I audible?
Yes, you can go ahead.
I think my screen is also visible.
Yes, it is visible.
Yes. Good evening, everyone. So today I'm going to present. Just wait a minute. Yeah, today I'm going to present on this topic: multilingual offensive speech detection in code mixed and romanized text. I am from BITS Pilani campus. My co-author is Dr. Ashwardhan Sharma from the same campus. So coming to introduction, so offensive speech is defined as speech that causes a person to feel upset, resentful, annoyed, or insulted. So detecting and eliminating offensive speech is important, really important, because of the serious consequences it can have, ranging from ill education among the students to even hate crimes. And offensive speech identification in countries like India poses additional challenges due to the usage of code mix and romanized variants of multiple languages by the users. In India, there are many languages used by them, and they often mix them in different ways to convey the message. So it poses even more additional challenges. So coming to the datasets provided by the organizers, so it's like this: code mix Malayalam, Tanglish, and Manglish. There are three types of them. So it code mix Malayalam consists of Malayalam hate speech in Malayalam script and also in Romanized script. In Tanglish is just means Tanglish is Tamil plus English, and Manglish is Malayalam plus English. I think the organizers has well explained in the 16 on the December 16th presentation, so I can just skip it. And there were two binary classification tags. Okay, we have to given a YouTube comment, we have to classify it as offensive or not offensive. Yeah, so coming to our approach for this task, so we use recent developments in multilingual text classification are led by transformer architectures, particularly Mbed and XLM Roberta. And transformer networks are proved to be better than other traditional techniques like using logistic regression, SVM, and pretend embedding features, etc. An additional advantage of this architecture, particularly XLM Roberta, is that it provides us good results even with lower resource languages. This is really important for Indian languages which don't have established data sets. For example, if we say for English, there are like from other shared tasks and all, there are good data sets for offensive speech detection, but that's not the case with Indian languages. So in our work, we focused on using the transformer architectures in multiple ways, that is using pre-trained architectures, fine-tuned architectures, and ensemble versions of them. But there's a problem in directly using the transformer architectures on the Romanized or code mixed text. The problem is that the architectures are trained on languages in their native script, but not in the Romanized or code mixed script. For example, here is snap of language on which XLM is trained. If I take Tamil, on Tamil, it is trained on Tamil in Tamil script, but not Tamil in Tamil Tamil in Romanized script or even code mix script. So there's a we need some solution here to be able to convert our code mix or Romanized text to the script in native language. So we propose a technique called selective translation and transliteration to effectively deal with this problem. So it converts the Romanized and code mix sentences into their native language while preserving their semantic meaning. And why can't we rely on neural translation systems for doing the same? As it is obvious, we just can't go by that. If I take a completely Tamil sentence written in English, and if I try to translate into Tamil again from English to Tamil, that would give me really poor results. So just neural translation systems don't work here. So 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 this process called selective translation and transliteration, in effect what it does is that it translates the native language words into text and translate the English words into to text. For example, if I take a language called a Tanglish, so it will transliterate the native language Tamil words into text and it will translate the English words. So this, I'll show an example later regarding this. The idea of selective conversion is based on the observation that in social media, users tend to use English words when they can convey the a meaning better with the English word than with a Tamil or even Malayalam, the native language words. So this is the algorithm. Before that, I want to explain an example here. So for example, this is what our STT does. For example, there's a sentence called non-movie chakra, which literally means I'm going to movie in Tamil. So it will convert to this to this script. So it means non Tiruppu chakra in English. Sorry for my Tamil. And so in this, if we can see that the first and last words of Tamil are transliterated. I mean, this nan and chakran, they are directly transliterated into Tamil, and this movie, which is an English word, is translated instead of transliteration. It is translated into Tamil. So by combining this, we got this sentence. So this is the algorithm for doing the same. Given a sentence, first of all, we break the sentence into many words, and then for each word, we will do this. So we are going to detect the language script of the word based on the script. So if we, for example, let us suppose that L provided here is Malayalam. So if the word is already in Malayalam script, we ignore it. We don't need to make any changes to it. But if it is in English script, I mean, if it's not in Malayalam script, then it should be in English script. And so English words is a dictionary here, which we maintain like a big dictionary of English words. So if the word is present in English dictionary, then we try to translate it. And if it is otherwise, like if it's in Malayalam, so we will try to transliterate it. And after this, we'll combine to get a sentence. So this is the algorithm. So regarding the implementation of selective translation, so we used LangDetect API to detect the language script, and translation is done using Google Translate API, and transliteration is done with the help of BrahmiNet API. So this is till now this is all pre-processing part. Coming to neural network models, so we use mainly three techniques in our work. So first one is pre-trained embeddings. For this, we use XLM Roberta model. It's a large multilingual model trained on 2.5 terabytes of common cloud data in 100 different languages. So for pre-trained embeddings, the model gives us an output of feature vector of size 1024 for each word, and then we'll just take an average of all these words to get the feature vector for the entire sentence, and simply after this we'll pass it to traditional classifiers like logistic regression and SVM to class for the classification part. And the second technique we used is fine-tuning transform architectures. So we use three types of these architectures for fine-tuning. First one is multilingual but uncased, and then second one XLM Roberta, both base and large versions for fine-tuning, and we used minimal hyperparameter tuning. And we decided that sequence length should be of 70 based on the observation that around 90%, 95% of comments have less tokens than that. Now, ensembling transformer architectures. So, what's the problem with fine-tuning transformer architectures? Why it's not able to give as good results as this? So, this is the point here. The instability and variance of transformer architectures performance is the motivation behind the ensembling strategy. So, this variance of transformer architectures when we are fine-tuning is created by slight changes in hyperparameters, particularly random seed. So, and also it changes the distribution of training data itself. And the random seed of a model also affects the initialization of weights of the final classification layer, which we do at the end. And so, this part, instability and variance, is also observed by us in our experiments with XLMR based models. In our experiments, we observed that there is like plus or minus 5% F1 weighted score difference for task 1 and Manglish, and then plus or minus 4 F1 weighted score difference for Tanglish on validation data. So we went on with this strategy to improve the performance. And as I said previously, the random seed also decides which samples go into train and test. Thus, it affects the performance of the model as a whole. So we experimented with 10 different random seeds, which implies there are 10 different models which we are trying to assemble here. And we use soft majority voting to combine predictions of all these 10 models into one. Apart from these major ensembling strategy, we also use other ensemble models like XLM Robot base with Robotology and XLMR with Embed, etc. Now coming to results and discussion. So internal evaluation, we have performed it on validation data. We can see the results here. We can observe that XLM Robota based models are giving better results compared to other models. So for task 1, we have got a 0.93 F1 weighted score and so on for Tanglish and Manglish. So these are the final submission results. The final evaluation is done by the organizers themselves. So we are ranked first in task 1 and Tanglish and second in Manglish. So these are our results. Coming to conclusions and future work. So in this presentation, I presented about our submission in HASOP Dividend Code Mix 5 2020. We introduced a novel and flexible technique of selective transliteration and translation to deal with code mix and Romanized offensive speech classification dividend languages. It's flexible in terms that it can be extended to other foreign languages as well. And we use 3 different techniques using transformer model. And so this can be some of the directions for future work. That is developing techniques and tools to deal with agglutinative and inflection nature of Malayalam language. So by agglutinative and inflection nature of Malayalam language, here I mean that in South Indian languages, particularly Malayalam, so a combination of words are performed or like gives another new word. For example, we have a word called Surya and Uday. So when we combine it, we get something Suryodaya. So which is entirely different word. We call it Sandhi and Samas in Malayalam and Hindi. So to be able to develop techniques to effectively deal with this kind of inherent nature of the languages will be one of the direction. And also other ensemble models of classifiers like logistic regression on top of word embeddings with transformer neural networks is also good to focus on. Thank you, and if you have any questions, I'll be happy to answer.
Thanks, Siva Sai.
Yes, sir.
And if anybody has questions, they can post it on the chat. Otherwise, they can unmute themselves and ask. My question is, you said you used the BrahmiNet API. So this is the first time I'm hearing about this. So
Yes,
is it a published? Is it open?
Yes, sir. Like it is by CFILT IIT Bombay. I think we even have presentation here.
Okay.
Of the same.
Okay.
Language Technology Laboratory from IIT Bombay.
Yeah, IndicTrans library, that is also for translating back to Roman script and back to original script. That is also from IIT Bombay, right?
Oh, I'm not sure about Hindi translate. I'll look into.
Okay, thanks. This is a nice paper. And moving on to next paper, Ajis, and Ajis is online.
There,
So
I'm there.
yeah, Ajis paper is Ajis at HOSOC Dravidian Code Mix. You can share your screen.
Okay. Yeah. Am I audible?
Yes, yes.
Yeah,
The
okay.
floor is with you. Yeah.
Okay. Good evening, all. Today I'm going to present my experiments on hate speech and offensive language detection conducted by FIRE 2020, right? Conducted as a track and association with FIRE 2020.
Hi, Ajis. Can you put us a slideshow mode?
Slideshow. Is it okay now?
Yes, yes, thanks.
Okay. So, first of all, introduction. Offensive language detection is the process of distinguishing the offensive posts and non-offensive posts from social media text. So, as of now, we know social media text is flooded with a lot of code mixed language or code mixed text. So, identifying the offensive posts from those social media text or comments is an important problem nowadays. And offensive language should be removed from any publicly available text because it causes angry from the people who are reading it. So, and due to the increased usage of social media sites and online interactions, getting an offensive message is a common issue faced by the commuters. And the use of abusive language can even corrupt the chatbots, since chatbots are learning from the interaction with the human beings. So if we are using the abusive language, there is a chance or there is a probability that they even learn from that abusive languages, and they may use it in the future. So it is an important problem that might be that offensive languages should be identified from the entry level itself. And these are the major challenges associated with the offensive language detection. For a country like India, most of the people use their regional language for chatting, commenting, and tweeting. And we cannot restrict them, or we can't tell them to use a particular language for chatting or commenting. They may use their own language. So a number of languages are there in India. People use their own local language for chatting and commenting. And the second challenge is that it's a code mixing, the property of code mixing. Code mixing is the property by which a people, there is a mixing of two or more languages in the same script. Okay. So that's also a challenge. And use of non-native scripts is another property of social media text, which makes the offensive language identification a bit harder. And the approaches that only depend on the monolingual data usually fail on code mix data due to the frequent code switching behavior in the code mix data. So these are the challenges. And this is about the task description and dataset details. The goal of the task is to identify the posts containing offensive language in the Dravidian code mixed dataset collected from social media. And the dataset is divided into two parts, task 1 and task 2. The task 1 is a message level label classification task focused on YouTube comments in Malayalam. And task 2 is also a message level label classification task focused on Twitter data. And the dataset for task 2 contains two types of comments, say Tanglish and Manglish. Tanglish is a combination of English and Tamil, and Manglish is a combination of Malayalam and English. Okay. So this is about the datasets, and more about the datasets is also presented in the another introduction event that's also conducted as part of the FIRE 2020. And comes to the methodology. Mainly 3 types of machine learning models were experimented using 2 types of word embedding techniques. So I have experimented 3 types of machine learning models using 2 types of word embedding techniques or word representation technique. And first I will tell you the basic 3 machine learning models. The first architecture was a simple MLP classifier using 2 hidden layers. And the second one was a combination of CNN and BLSTM network with 4 convolutional layers. And the third one was a BLSTM stack with the 2 hidden layers. So these are the 3 types of machine learning models that we have that have tried to experiment. And in order to represent the individual words in the comments, the first experiment I have used was with the symbol count vectorizer. And second one I used was with the BERT. So usually in scenario where the dataset size is very low, the count vectorizer performs well better than the other word embedding techniques like word to BERT or any other thing. So I have included both count vectorizer and the latest BERT4 experiments. Count vectorizer is used to convert the text data into a vector of token counts. It also provides the pre-processing of text data before generating the vector representation. On the other hand, BERT is a pre-trained NLP model that provides contextualized word embeddings. That is, the dynamic word embeddings can be obtained using the BERT. And BERT can also consider the context of words before generating their embeddings. So these are the two types of embeddings that I have used. And regarding the experiments, first of all, the MLP based approach, that is the neural network based approach. MLP classifier with 2 hidden layers was used for the classification purpose. The complete training set is converted into numeric values using the count vectorizer, the Python functionality. The labels of each pose are converted to 0 and 1 depending on the label. A network with configuration that is 2,200 was used for the experiment, where 2 is the number of hidden layers and 200 is the size of the hidden layer. And in the second, this is about the first experiment, that is the first architecture. The second experiment is using the deep learning approach. For the deep learning approach, I have employed a CNN by LSTM architecture. So the first layers are CNN, the convolutional layers, and the hidden layers are by LSTM layers. So the CNN layers will convert the words in the training data into its corresponding embedding. So CNN layer will do the process of conversion of the word indexes to its corresponding embedding metrics, and the by LSTM hidden layers will learn the hidden features within the words and within the sentences. And then the training data was 0 padded to make them into uniform length. The sequential model of Keras was used for the model construction. And the next is the another deep learning architecture that we have used. It is a continuation of the first method. It's a second method. The network was configured with 4 convolution layers and 2 max pooling layers, 1 dense layer and an embedding layer. The embedding layer is the first layer that performs the word embeddings. The second layer is a convolution layer for its ability to capture the local context. The following max pooling and convolutional layers were arranged in an alternate pattern for acquiring the patterns within the comments bar posts. This is the second deep learning approach. That is the third total approach. So we have used 2 deep learning approach and 1 shallow network approach, that is MLP approach. So this is the second deep learning approach, and it was a by LSTM stack followed by dense layers. The hidden layer containing 300. The hidden layers are created using 300 neurons with a TANH activation, followed by a dense layer of 100 neurons. The final layer is also a dense layer with a softmax activation unit. And here the input layers were provided with the BERT embeddings as input features. So for the first architecture, we have used count vectorizer as the embedding unit. The count vectorizer is used to convert the words into embedding vectors. And for the second and third architecture, we have used BERT as the embedding unit or embedding feature. So these are the results that we have obtained for the various configuration. When we have used 2 layers, 3 layers configuration, but we could not find any major change in the accuracy with this architecture for the count vectorizer, the first architecture with the count vectorizer. You can see an overall accuracy of 93.75 was obtained for this architecture. And for the second architecture, for the third architecture, that is the second architecture, by LSTM with BERT feature representation for task 1, we got an accuracy of 92.5. You can see the simple count vectorizer was outperforming the high quality BERT in this task. That is because of the less amount of the training data. Okay. If the amount of training data is huge, we can see the BERT based feature representation will overtake or will overcome the accuracy for the architecture. Okay. So this is the conclusion. We presented a naive approach towards classifying social media posts in Dravidian code mixed text for hate speech and offensive content, and no external resources like collection of abusive words, negative social media comments, code mixed abusive text, etc. were used for the experiments. And more improvements to the results can be made by incorporating external resources like a collection of abusive words and code mixed abusive text, negative social media comments, etc. as additional features. Since I have joined in the competition that last moment. I could not do a much extended survey regarding the topic. So I was not able to perform very well in the competition. That's so, and I apologize to the organizers for not making that much effort in the competition. Okay, that's all. Thank you.
Thank you, Ajis. Before you log out, so please send the PPTs to IRLAB, DIACT, and Zoom search. And
okay, I will just send to Bhardiraja. He's online, right? Is it enough?
Yeah, I am Bhardiraja. Okay, thanks.
Okay.
Yeah.
Okay.
Okay, thanks. Next, our presenter is Pankaj from IIT Bombay, CFILT. Their paper title is Assisting Ensemble of Transformers with Random Transliteration. Pankaj?
Hello, good evening, everyone. So I will be sharing my screen.
Yeah, we can hear you. Yeah, we can see your slides. Floor is with you.
Yeah. So his slides are visible.
Yes.
Hello. Okay. So I will begin my presentation. So my paper was titled Assisting Ensemble of Transformer. I am Pankaj Singh and I will be presenting this paper on the behalf of both authors. So this was our entry to the HASOC Dravidian code mix share task. And we have participated in all the 3 tasks, and I will share the analysis and results of our system's performance. So this was the motivation. This graph shows the projection of internet users in India. So currently we are at 2020 and we have around 700 million internet users, and we are projected to grow to around 974 million by 2025. So it shows that the number of internet users are in India are growing. So we need some hate speech or offensive detection along with other systems which we can monitor the online social media content. So this shows how important it is to build system for local Indian languages as well. So this shared task focuses on building hate speech and offensive detection system for Dravidian languages, specifically for Malayalam, Tamil. And these are the challenges in the previous 2 presentation. Also, these were extensively discussed. Transliteration, code mixing, and script mixing are main challenges when we come across the users of India in social media. And this is the analysis of the result for this particular shared task. We had 3 tasks. First was in the Malayalam, so there was a data set was a little bit different than the task 2 of Malayalam. There was script mixing also present, so, and there was also class imbalance present in the task 1. So only 16.5% of the data set with hate speech, which reflects the actual scenario, because in the actual real world case we will have a lot of data which will not be hate speech, but a less amount of data will be hate speech. So this class imbalance will be mimicking the real world scenario. So it is important to consider this factor, because this will impact the overall performance of the system. And the key techniques which help us improve the results were data augmentation using random transliteration. So I will explain in a bit how did we do this data augmentation part. And this was the proposed architecture. So we were basically using the multilingual BERT. So multilingual BERT was trained on 104 languages. So along in this 104 languages, we had those Tamil and Malayalam also included. So basically we have a simple system. We obtained the multilingual BERT embedding, and we use a fully connected layer. Sometimes we had to use 1 or 2 additional fully connected layer before using this softmax, depending upon the task. So this was the overall system architecture. The query was processed via this multilingual BERT. We will get the 768 dimensional vector embedding. Then we will process that embedding via fully connected networks. And at the end, we will do this softmax layer and do the classification for binary tasks. And this was the fine-tuning strategy. In original paper of the BERT, actually author mentioned that we should fine-tune all the layers all the layers at once, but that did not perform very well. So we had an alternative fine-tuning strategy. What I did was, for example, for first few epochs, I only trained this uh, first layer. Then as the epochs number of epochs increases, I unfreeze the other bird layers. For example, for first 4 epochs, the bird parameters were freeze, they were not trainable, but later I unfreeze those parameters. So this strategy is very common in computer vision problems. So I adopted this strategy from there. So this strategy resulted better convergence of the loss function rather than making the entire BERT architecture trainable at once. And this was the data augmentation and training by random transliteration. So for example, this is our original text. In the task one, there were text, there was some Malayalam text which was, for example, in Roman script as well as in Dravidian script. So for example, this is the original text, and this is what is the output of the transliteration module from the mm, Google Transliteration or other some other transliteration off the shelf transliteration systems. And if this is the original text, this will be its English transliteration system. So with during training, what I did was with the certain probability. For example, with certain probability of p, that p value was hyperparameter, and we established that 0.3 was performing giving the best result. So with the probability of 0.3, this sentence will be transliterated to this, and the system will be trained on this sentence rather than this. So we had this transliteration of original text to a other script, and this was used as a augmentation strategy for the data set. And at the end, we ensemble all the transform model. So we observed that the transformer models individually were performing actually good, but they were mistakes they were making were not very similar. For example, we have these three transformer model architecture we have tried. So architecture is same, but the training and fine tuning strategy is different. So they were making mistakes on different kind of the text. So we used this ensemble or transformer to have a hard word ensemble, and the errors could be minimized. So the first model was fine-tuning multilingual BERT on the binary cross entropy loss, assisted by the data augmentation using random transliteration. This is the model and strategy I talked about earlier. The second was transliterating the entire data set on the Dravidian script and fine-tuning on the multilingual BERT on a common script data set. So I make the script of input sentence uniform, and the script was only Dravidian, so there was no Roman script present. So this was the second type of model we trained on. And third was we trained our system on weighted binary cross entropy loss. For example, initially we saw that the number of hate speech data in the task one was 16.5%. So it was actually important to have a good recall on those hate speech texts, because the missing of those texts might be more hurtful for our system rather than uh, predicting a normal sentence as hate speech. So this to increase the weight of those less presented class in our data set, we use this weighted binary cross entropy loss, and these three models were later ensembled and the final prediction was made. And this was our results published by the organizers. In the task one, we have obtained the precision of 0.94, recall of 0.94, and F score of 0.94. Actually, the recall parameter is more important because we want to recall all the hate speech text which is present in our data set, uh, because detecting the hate speech and offensive content with more accuracy is more important than mispredicting the normal text. So in the first task, we obtained a second rank, and in the later two tasks where we obtained sixth and fourth rank respectively, and these were the number published by author on our system. So in the conclusion, we established this efficacy of data augmentation strategy and using the multilingual transformer embed models for hate speech and offensive detection tasks. So in later, we aim to develop a single system for hate speech and offensive system, because in India, what we have is we don't have a single language, but we have more than 20 official languages which are very popular. So it is not possible to have a multiple system, each the task is specific system. So what we want to have a single system which can perform this hate speech and offensive detection task for multiple languages at once. Because if we want to deploy the system online and monitor the online content, having this multiple system will run into memory and latency issues. So with the help of having only one system, this memory issue will be decreased. Also, we will have a less amount of training time if we have a single system for all the Indian languages. So this was the conclusion and the presentation from our side. If you have any questions, you can ask.
Thanks for your presentations. I will give the chairing session to Prem, and he will be chairing the other sessions. After that, they will go to the talks. Thank you.
Okay, thank you.
Okay, thank you, Bharati. Can we have 10 minutes break before starting the next session?
Okay, before we go to the next session, actually, I'm sorry to interrupt like this, but yeah, Professor Adam Weiner has already joined the call, already joined the meet, and we will have to start with the with his invited talk, because he may have some other duties as well. So I think before we move for the it's absolutely fine, Professor. I think we will start with your talk now.
Okay, thank you.
So yeah, welcome, Professor Weiner. And the talk he is going to give on is developing resources for legal information retrieval.
Thank you. I need to share screen. Do I have power to do that?
Yeah, you have it. You have it. Yeah.
Okay. Let's see. I should get. So I should be able to choose. Okay, here we go. Okay, can you see my screen there?
Yeah, I can see your screen. Yeah.
Perfect. Thank you very much.
Okay.
Thank you very much for this invitation to speak at this FIRE meeting. It's a great opportunity to build on collaborations that are ongoing between myself and colleagues and students in India about legal informatics. So in a sense, having the Zoom talks has created an opportunity for more conversation, that's a bit more remote than usual. So the talk that I have is a bit of publicity, in a sense, for this topic area in legal informatics, which may be unfamiliar to the broader audience, but I think offers a tremendous amount of opportunity for research and development. This kind of research and development is already starting in India, and this is part of the collaboration that I have with colleagues there. So this is kind of a reinforcement and expansion on some of those topics. It's intended really to just be an informal kind of talk. I'll have a little bit to say about the specific work that we did in this collaboration, just by way of kind of giving a concrete instance of the kind of work that's possible. And also to say that, I was very glad that we got to have this collaboration that was so productive, and it's good to have evidence of these kinds of things. So I'll talk a little bit first about some of the problems with legal service provision, and then talk a little bit about the broader landscape, turn to then talk a little bit about the collaboration and the results that we got, and then end up with a view on the opportunities that I think are available to research and development in legal informatics in India, and also more broadly connected really throughout the world. So I appreciate that everything that I have to say is highly localized to the UK context, but I think that what you'll find is, for instance, when I talk about our collaboration, that this really applies as well to the Indian context. And there are many things I don't know about India, many things. So please forgive me for some omission or these kinds of things. So the first slide is to say that there's a huge landscape of what are known as legal services. This is a little map that I made for myself and my students in the UK. It's a map of different legal services that are provided to citizens or that need to be provided to citizens. And this is only 2 pages out of 4 or 5 pages that I compiled. I know the font is very small because it's just to give you an impression about the many diverse topics about legal services. Now, generally what happens with a legal service is that somebody, a citizen or a business, has some kind of problem that they need to solve. Maybe it's to sign a contract, maybe it's to get divorced, maybe they want to complain and have a compensation for the complaint or something like that. And traditionally what they've done is they've gone to a lawyer and they've paid money to a lawyer and gone through a whole legal process to see their legal service provided. What's increasingly happening is that the field of legal tech is opening up a lot of these legal services to some form of automation online. Okay, so just to pick one at random, environmental justice there's a matter of hazardous waste. Suppose that you're living in a community and you want to file a complaint and get some compensation about some hazardous waste that's been dumped in your community. Let's jump over to something like housing and real estate. There's the line there about owning or buying property. If you're going to sell your home or you want to buy a home, there's a whole sequence of processes that you have to do in order to secure ownership or to sell your property. These kinds of things are very often beyond the knowledge and skill of any individual citizen, us, right, who are in the community to be able to solve. And we very often try to look for some kind of expertise to help us solve our problems, right? And the idea of automation would be to start to provide some way of giving a web-based interface to a tool that can provide you with legal expertise, gather your detailed information, provide you with legal advice, help you fill in documents, and perhaps carry on to consult further with a lawyer. And I'm not saying here about legal services that we're talking about automated justice. That's not what we're doing. We're not talking about robot lawyers or the laws, the Asimov's laws of AI or something like that. We're just talking about providing services to the broader community. Again, about the Indian context, this is a list from the UK and the US, but I am rather sure that a lot of these kinds of legal services are also highly relevant in the Indian context across the different states, across the different languages. Here it's just presented in English, and there are probably other topics that I have missed out in this list, okay? So this is very general. Problems with legal services. There's information and processes related to the law, I've just outlined those. The legal service must be provided to citizens, businesses, organizations, as well as between the government, right? The government has services it needs to meet. What is served and who is served is highly heterogeneous. Many different kinds of people need this help. The legal system everywhere is overburdened by cases. It's understaffed, it's underfunded. Now, we may be talking about legal service support tools for the lawyer in their office or in the field, or we may be talking about it available online to the citizens. So there's a diverse range of ways that legal services could be delivered, but we know that this is a gigantic problem. Now, if justice, whatever justice means, but the solution in the legal services context, if justice is not properly, clearly, and efficiently served, then there's all sorts of negative impacts on individuals, society, and business. This is a huge point of friction in society. And it's not just that we're doing good to get justice for individuals who have been wronged. We're also talking about having good things for business, right? Which will then allow businesses to grow and to thrive and to flourish. So what are some of the ways that we can upgrade our legal services and to reduce this kind of friction? So we have large and very complex corpora of unstructured legal texts. This could be primary, secondary legislation, regulations, case law, etc. This is the kind of thing that law school students learn to analyze manually. For computer scientists, for this community, this is a very large and very diverse corpus of documents. Now, if you're a computer scientist, you don't know about the legal concepts. You have to learn something about the legal concepts. What is a prohibition? What's an obligation? What are the different classes of individuals? How do different rules apply, etc.? So this unstructured corpus of legal text has a lot of legal concepts, and these have to be properly and thoroughly understood. There has to be reasoning about the law, including exceptions. You know, you may very well find a regulation that says this must be done except in the following circumstances. There are a great many complicated matters about language, about linguistics, ambiguity, interpretation, vagueness. People in the information retrieval context who work with language are very well aware of many of these kinds of contexts, of these kinds of issues. And as well, there's the matter of working with a variety of languages. India has what was it? What was the number we just heard? 26 or something like that, different languages. The UK also has several different languages. I'm now living in Wales, working at Swansea University, and Welsh is a very widespread language in Wales, and it's a very different language from English. In Scotland, they have Gaelic, which is a very different language from English. And the issue there is that you need to serve the law in these other languages, not just English. It must also be in Welsh and also be in Gaelic. And so this raises very similar kinds of issues as in India about managing the law, which is in effect one thing, but in different languages. And also the legal service has to be relative to the context and the users, right? This is another layer of complexity of this kind of problem. There are a great many legal jurisdictions, that is contexts in which the law must apply, whether this is across states, whether it's federal national law, whether it's customary law, just the practice of a community, whether it's religious law. And again, these are phenomena that are not unique to India or the United Kingdom, but many countries have similar kind of issues. I'll return to that. There are heterogeneous information and processes that have to be done, whether it's an appeals process in a court proceeding, or whether it's divorce proceedings or land purchase, etc. All of those legal services I pointed out before. There's an enormously diverse range of users, from the person who does not read and write, but nonetheless needs their rights defended by an attorney, to the Supreme Court justice, who also wants to have tools that will support them in their activities in the court. It's a very, very broad and diverse community that needs to be served in different kinds of ways. And we want to also have not just sort of atomatize the legal services, but we would like these to be integrated. The services need to be able to converse with one another, transport information across the users and across the applications so that we have integrated flow of information. This is another gigantic kind of challenge. So how can we process these corpora and the processes for the users and the systems to a very high level of quality that serves the needs of the legal system? Let me emphasize this point about high level of quality, right? It may be fine in most information retrieval contexts to have a result of, let's say, I don't know, F1, let's say 80, good, 85, 90, fantastic, right? Is that level of quality results good enough for the legal system? How many people are you willing to wrong because the quality of the results is not sufficiently high, okay? And this is a very significant issue for the court systems and for the justices, because they want to be sure that the automated system does not introduce any more problems than they already have, okay? So the quality of results needs to be very high. There's a separate issue about whether or not the legal system would like to have automation. I won't talk about that, but there's really some significant grounds to be concerned about this, and particularly about transparency of the results and the processes. The legal system, at least ideologically, lives on the concept of transparency so that there's going to be confidence and trust. in the process of the legal system. So I just want to flash quickly through several use cases. I will no doubt be interrupted when my time is up, and so just give me time. Let me know when my time is getting short so I know where to jump to. I just wanted to show a few slides about some use cases. I won't go into things in depth here. So here's an example of legislation. I know this is very small to read, but just to have a picture of this. This is a particular piece of legislation in the United Kingdom about British citizenship. Who is a British citizen, who can get British citizenship, when is British citizenship stripped from somebody. Here you might have questions like, what are the rules? What are the connections between the rules and within the rules? You have arguing a case, arguing a legal case before a court. One of the things that happens in arguing a legal case is that you have to look at precedents as well as the law books and the statutes. But often you look at the precedent cases, those that are decided, and you make a kind of comparison and contrast between the precedent cases and the current cases, trying to identify a precedent case that's most useful to you in helping to decide the current case. This is case-based reasoning, right? So how do you find the precedents, and what are the relevant portions of the precedents? And we'll talk about that again later. There's contract negotiation, construction, execution, compliance monitoring. There's a little contract there, right? You want to know who are the parties, who is obliged to do what, how do you assess whether or not the contract is being complied with? Legal consultations, this is the closest one to legal services. So you have, let's say, some kind of online calculator for whether or not you as a user are entitled to some particular kind of benefit. The citizen gets online, for instance, or the legal advisor, let's say in an office or in the field, if they can get a connection to this, right, could use a tool that's online and input the data from the client to be able to determine whether or not they're entitled to some kind of benefit. I again realize that this is a particular instance drawn from the UK, but these kinds of concepts and tools could be localized and adapted to the Indian context to a greater or lesser extent, or completely new ones, right? So a lot of other use cases, mediation, I'm just jumping around here, right? There's document classification, there's the e-discovery. How do you discover what evidence there is drawn from emails, right? Searching through electronic data for indications of criminal wrongdoing. How do you do intellectual property, establish intellectual property rights, or doing patent law? There are many other kinds of use cases. Each of these has a corpus of documents and subcorpora of documents and has a particular range of applications. There are also many legal topic areas. I sort of touched on this earlier with the legal services, but this is some areas that are not tied to legal services. Military justice, again, jumping around, Islamic law that may be highly relevant, consumer protection law, these kinds of things. So there are many different kinds of legal topic areas. So this is to sort of introduce the diversity of materials and topics that might be addressed. Just a few slides on something about landscape to give you a sense about a little bit what's going on. In the UK, Europe, and the United States, there has been, within the last 4 years, a huge leap in interest to develop legal tech or artificial intelligence and law, right? So here it's called legal AI or something like that. If you asked me 5 years ago, what was the status of AI and law or legal tech, I would have said, the law firms don't care. The government is not interested in investing, and there's no startups, right? If you asked me about 4 years ago, there's a little bit of interest, but not so significant. About 4 years ago, 3 years ago, there was a very significant expansion in interest in this area by startup companies, by the government, and by large legal informatics companies. And this just gives you a little picture that was circa, actually, 2018. This pictures are a little bit out of date, just to show you, there are some topic areas and some companies there. So contract review, Law Geeks, Beagle, Thought River, etc. Another area is legal research, Judicata, Ross, Case Text, etc. And since then, there have been a lot of other startup companies in these areas and in other areas. And there are conferences that are devoted to legal tech that show a lot more information about startup companies. To my knowledge, there are, and I apologize if I'm missing something, and I would love to be informed. To my knowledge, there are not any that I'm aware of legal tech companies coming out of India. I will remark on this later because I think this is a wonderful opportunity for people to get involved in developing companies or developing applications, doing things for the government and doing social good, okay? The whole kind of story there. So there are a lot of other contexts, and we can say more about that. I also want to say something about how highly interdisciplinary legal informatics is. It integrates things from computer science, which you're much more familiar with, as well as concepts from linguistics. You have to know something about the law. And what this means is not that you're a lawyer, but that you collaborate with a lawyer who has expertise in identifying the structure and sources and concepts. There's lots of issues about public participation. Who do you serve? How do you serve them? And there are topics about management. Yes, did somebody wanted to say something? No? Okay. Just if I needed to be interrupted, that's fine. There's a lot of areas about management and government that need to be brought into this as well. The implication here is that legal informatics is a highly interdisciplinary, team-based endeavor. You need to have a diverse group of people collaborating on a joint project, coming to a common understanding about the problems, the resources, potential solutions in delivering on some particular kind of legal service. So I wanted to say some things to give you a bit of meat on the bones about a collaboration, just show some substance about the collaboration that we've got on a particular topic area in this, so that it's not all just, well, hypothetical and we can do various kinds of things. So this is an India-UK collaboration and a deep learning study of a corpus of legal cases. And for this, we got a URIX, which is a legal informatics conference, annual legal informatics conference in Europe. We got the best paper award. While I'm here, let me just say that URIX is a conference which would certainly welcome papers from this community on legal informatics. The colleagues in India who I've collaborated with and some of their colleagues have contributed and have been successful in getting into this conference. I also should add that I'm the program chair for the International Conference on AI and Law in 2021, which is going to be held in Brazil, but there's going to be a significant remote opportunity there. So this would be a place where people can also make contributions. So the work that we did is revised and has been revised and has been submitted for a journal publication. Could I get a time check, please? Just somebody tell me what my time is like left.
You have about 20 minutes left.
20 minutes. Okay, well, that's overly generous. I won't go through this in great detail. Thank you very much. Okay, so I do have some time to go into this collaboration. There's a lot more in the paper, which I'll show you how to find. And I'm not going to go into the technical details. You've heard many papers, I'm sure, that give you some great detail. I just want to give you a sense about some of the high points about that and to sort of outline a little bit about this point I made about collaborations and interdisciplinary work. So there's the title of the paper, Rhetorical Roles of Sentences in Indian Legal Judgments. So we focused on a corpus of Indian legal judgments made in India. There's the list of the collaborators. The first two, Paheli and Shunak, are students in computer science. Kripa and Saptarshi are, one is in a company, another other one is in an Institute of Technology. These are the colleagues that I worked with, and then myself. So primarily, we're all seeing this from the point of view of computer science, right? And I've done a lot of work in legal informatics, so I had some expertise to bring in about how do you work with these materials and where do you find them and some aspects of the analysis. The other thing that happened is that they did a collaboration with law school students at the law school that's part of the institute or affiliated with the institute. So we had a team of law school students, and as well as some consultation with law faculty in carrying out this particular study. So, that's a part of the point about this collaborative nature of the work. So the goal here was to automatically identify the rhetorical roles of sentences in a legal case. I'll say something more about what is a rhetorical role. The solution should help with summarization, search, and case law analysis. My colleagues in India started out in their work with a significant interest in summarization, and they're bringing their expertise in machine learning and the tools that they have at hand. We worked with unstructured text, in this particular instance, 50 documents from the Supreme Court of India, which is all written in English. And this is a point I'm going to return to later. We created a gold standard that's annotated by the human annotators. And over that, we carried out studies on automated recognition, creating a model. We carried out this automated rhetorical role identification using deep neural models, which do not require handcrafting of features. So the two key points of the results here is that they do not require handcrafting of features, one. The other is that we had a high performance across document domains, which has generally been a constraint. So these experiments that we did show that the neural models perform better than the baseline models using handcrafted features. So those are some of the general points. So there was an exploration of two neural network models, the hierarchical by LSTM model and the hierarchical by LSTM CRF model. We did supervised classification across 7 rhetorical labels, that is the classes, and over 5 different legal domains. I'll say something shortly about that. And the hierarchical by LSTM CRF model achieved very good performance, as I'll show, across the classes and across the domains. What was also very interesting and a bit novel, I think, about the study that we did is that we carried out a detailed inter-annotator study, and we compared that to the performance of the models, the best performing model, and we found that the subjectivity between certain pairs of labels, in this instance, ratio versus precedent, or 2 rhetorical labels, that are found in the human annotators are also reflected in the predictions by the algorithm, okay? So that there was a matchup between the subjectivity. For the algorithm, what that meant is where the errors arise, right? For the human annotators, that's where they have disagreement. So a little bit about the data set. We used the Supreme Court of India judgments. We had several domains: criminal, land, constitutional. So they're across domains within the law, not domains that are different from, let's say, business contracts or, that are outside the law. So it's within kind of one large domain, Supreme Court justice decisions, but within that several topic areas, because the vocabulary would be different. Here are the rhetorical labels that we had. I won't go through these in detail, but there are a variety of things, like you have to, in a legal case decision, identify where the facts are, what statute might have been referred to in the legal case, what's called the ratio of the decision. That's the reasoning on the points of the case and the applicable legal principles. And then at the end, you have the ruling by the court. What's the decision at the end, whether guilty or innocent, okay? So these are the 7 classes that we annotated through the text, which literally meant that our annotators took these legal case decisions, they looked at the rhetorical labels that we had, and they went through the decision to label sentences or passages in the decisions with respect to these different classes. So there was an annotation process. We focused a lot of energy on the annotation process so that we really understood this very well. And I think this is a very interesting and important aspect of the overall machine learning cycle. We did a manual annotation and we created an annotation manual. We did this detailed inter-annotator agreement study, and we did a curated gold standard. And we were focusing a lot on the annotator agreements portion to produce some additional results. So this is an example of an agreement matrix. Along the diagonal, right, going from the top left to the bottom right, you have where two annotators, A2 and A3, agree that a certain passage is annotated. I hear some noise from somebody, so I think, Parth, there we go. Thank you very much. There we go. Along the diagonal, you see where there's agreement, and outside the diagonal, you see portions where the annotators disagreed. And you see that there are some portions where there was rather a lot of disagreement, like RLC and FAC, right, have 47 instances where they disagree. Or when you look at PRE and the ratio, you have 47 instances where they disagree. So there are other places where there's some disagreement of a lesser value, but there are some portions where there is an indication of some significant disagreement. And we did this for each of the pairs of the annotators to highlight where it was easier to agree and where disagreement arose. This is very interesting, right? To see that there's this kind of disagreement. Is that because our annotation manual, the instructions are not sufficiently clear, or does it suggest that there's some really important ambiguity or interpretive matter that needs to be further picked apart in order to further narrow the possible annotations here? So this is something that's worth investigating more. In a kind of context of these texts, which have very complicated kinds of language, it's more and more important to really find a common understanding about what the labels mean and how to identify passages in a reliable fashion. Even law school students have a great difficulty in this, and even lawyers are very well known to disagree about the interpretation of passages. So here's a bit about the results, right? I don't want to go into this in great detail, except to show you that the highlighted portion, that's the hierarchical bias TMCRF model, had the best performing, the pre-trained embeddings had the best performing precision recall and F scores across the board. So we used a variety of other models, baselines, and 2 neural models to test. And we have some additional ones that were trained in the new paper, as well as some additional corpora. So those are pretty promising results, as well as to show results that the model performed rather well across the different domains that we had, constitutional, labor and industrial law. Sorry, let me skip labor and industrial law. Constitutional, criminal, land and property, intellectual property. As you can see from the macro averages, the performance is uniformly rather high. Then there are some comments to be made about the performance in the labor and industrial law context, and I'd have to ask my colleagues to remind me about how that happened, but I think it had to do with the scale of the corpus. I'd have to remember how to do that. And here's the other thing about the results that we thought was interesting, was to compare the human annotation results, right, the predictions, against the model, what the model predicted. Sorry, the human annotators versus what the model predicted, okay? Now, if you go again across the diagonal from the top left to the bottom right, you see that by and large, that there is agreement between the human model and the automated model, or the human annotators and the automated model. And yet you also see that there are some points of disagreement. Sometimes there are points of disagreement that are higher than what we had for human to human, right? So argument compared to fact. But you also see that where the ratio and the FAC disagree, that was also a place where there was a lot of disagreement between people. Also, if you see the ratio versus the PRE, that's 72, that's another point at which there was significant disagreement. Or another point was the RLC and FAC has 33. That was another point that we had some disagreement. And there's other things in this data worth looking at, but it was interesting to us to see this kind of relationship between the issues that human annotators had and the issues that the model came up with. And this is something we think is worth investigating somewhat further. I'm sure that my colleagues who are more specifically involved in the technical aspects would have more to say about this than I do at this point. So broadly speaking, the machine learning models did better identifying rhetorical roles compared to methods using handcrafted features. We did this extensive annotation study. We know that machine learning models tend to be opaque, right? It's difficult to understand why a sentence is classified one way or the other. Now, the point why this is important is that in some fields of doing information processing, opacity is not a problem. You might not really care whether you can explain, let's say, face recognition, right? And part of the reason I think we don't really think that's terribly important is because we don't have any intuitive idea for ourselves about what constitutes face recognition. We are able to do this as kind of more or less a high-level reflex. That is not the way that it works in law, and importantly, it's not the way that the legal system, it's not what the legal system demands. The legal system demands some kind of explanation, tracing the reasoning, and also that reasoning must very often be tied to some specific textual portions, right? So there must be some explanation and it must be tied to some textual portions. So explanation and transparency about how you got the results is really very important in a legal context. So classification is very important. And to the extent that machine learning models can provide explanations, they will be more easily used in a legal context than in other kinds of contexts. Let me give an example of why this is important. Suppose that this is the worst case scenario that I've sort of come up with, right? Suppose you have 1 million death penalty cases in the United States, and I regret that this is what's going on in the United States, but suppose that there's a corpus of 1 million death penalty cases. 500,000 of those are guilty, death penalty. 500,000 of those are exonerated, not guilty, right? And you apply the best machine learning algorithm that you've got, and it gives you perfect results, right? It makes the accurate predictions exactly as your data says. The question is, would the legal system accept this kind of automated adjudication as the way to go forward? And the answer is no, even if you have the best results. And unless this machine can explain in great detail that's accessible to the lawyers and the legal community why they've arrived at their decision. And the reason why it's not acceptable unless it's really transparent and explainable is because legal cases go on to appeal. That is, just because a decision is made may not be sufficient for that decision to stay, right? So you say, I'm innocent of this death penalty verdict, and I'm going to take it on appeal to a higher court. And that higher court must know in detail why the preceding cases was decided as it was, okay? And this is based on the text of the decision and all of the evidence that was provided and the arguments that were made. So even if you have an outstanding machine learning model on perfect data, there's still going to be substantial kinds of questions. So, okay, and then there's some further work that we have in this kind of area. Now I want to talk briefly about opportunities. I want to specifically tie this into the Indian context. I think I've a little bit made this case earlier, and I want to go back to it. I already said the general point that there's a great range of legal services, and the demand is enormous, right? And you would only have to ask colleagues who are in legal practice in India to find out exactly what the enormous problems are. We already know that the data and processes are highly complex and highly heterogeneous. Every lawyer will tell you, or legal professional will tell you, that you can't automate things, and you can't, the process is too complicated, and et cetera. The data is too deep, and so on. And so it's seen as almost an insurmountably difficult task to address. Nonetheless, there are a lot of opportunities for research and development, whether for commercial advantage or for the social good. I happen to be very interested in the social good. I find that very interesting to contribute to. And I think it's a fantastic research and development context. And the way forward is, out of this very large and very complicated and very deep problem area, to divide it up into something smaller. something more specific, which is what we did in our study, right? Look at a specific kind of material, address a specific kind of area, identify some kinds of tasks that you wanted to serve, and then really dig into that. And a lot of the services that I outlined before, you could do similar kind of thing. Then specifically about India. So India has enormous complexity and richness. You know all of these things. I'm just saying them to put them on the table and also by way of encouragement, right? There's a complexity and richness in the Indian context about languages, the law, different kinds of laws, different kinds of jurisdictions. This also appears elsewhere, as I mentioned, in the United Kingdom between England and Wales. A small project that I recently had supported is about Welsh law. England and Wales are in fact two nations within the United Kingdom, and England and Wales have a joint jurisdiction. That is, there is one joint law book about the laws of England and Wales. However, there's been a process of devolution. That is, Wales now has its own parliamentary assembly. They are endowed with the competence, it's called, the competence of writing their own laws that only apply in Wales. And what the Welsh legislators want to do, what Welsh government wants to do, is to disentangle this currently joint law book apart so that they are able to identify Welsh law versus English law. And this is important because if, let's say, a business is operating both in England and in Wales, that company needs to know what specific laws apply in their particular legal jurisdiction, because they may no longer be the same, okay? So the same thing happens in other countries that have a variety of states and have localized laws as well as federal laws that apply to them. Another country that's very complicated is something like Nigeria. Many, many languages, many cultures, different kinds of legal practices, as well as many other kinds of places, okay? So a context that India has about the complexity and richness is found elsewhere. The point is that the solutions and generalizations that are developed in India about different languages, different jurisdictions, etc., can be, with adaptation and localization, ported elsewhere. I think that's a useful way to think about it, right? Don't see this as a disadvantage. It's actually a strength to be able to figure out how to work across these contexts. More things that I know that you know, and I just want to say them because I think that they should be seen as, you know, opportunities for really getting into this whole topic of legal informatics. We know that there's an enormous talent pool in India in computer science as well as in law. Now, the thing is, it's tempting to see law in India as just law in India. But actually, thinking about law very often is very common across countries. There are some particular laws, some particular practices, some particular names of things, but there's also a great deal that's in common. And both of those areas of expertise in computer science and law are areas that can be integrated and work in collaboration. A very big advantage in India is that the law is often in English. There are also localized laws written in languages. But what that means is that work that's done, for instance, such as what we did, right, about Indian Supreme Court justice decisions, those tools can be applied to, let's say, the United Kingdom, the United States, Australia, etc., other English-speaking context jurisdictions. There is in India, obviously, a very high level of English competence that can be used for analysis of law, because law requires very intense analysis of the language of the law and a lot of heavy discussion about what things mean. It also offers the opportunity for highly networked collaboration across the English-speaking world. And the small project that we did is just an instance of something that could be much larger and be very successful. The thing that's mostly lacking is funding support for research and development, as usual, right? It's actually quite difficult to find funding that is in this kind of interdisciplinary niche. The one thing that I think is very, very promising is that there's at this conference, there's the track on artificial intelligence and legal assistance. This has been going on this year and previous years. And it's an area where I would certainly encourage people to make contributions, as well as, by the way, bring colleagues into this larger context of URIX, ICAL, that is this kind of global legal informatics research and development community. So that's what I have to say, and I welcome questions. Thank you for the opportunity to address you and to be in further contact, and I look forward to this developing further. I'm going to stop share, right?
Any questions from the audience?
Hi, I have a question. First of all, thank you very much for the wonderful talk. It was quite comprehensive, and it was refreshing to see the industry perspective as well, like how things are there in startup world, which is something that we usually lack when we work with legal informatics. So my question for you is, you mentioned that there is this sudden spike in interest in terms of industrial research in this field. Is this just another part of the general interest of that's developing about deep learning, like using deep learning in everything or machine learning in everything? Or is there a more nuanced reason, like something has changed which has motivated more people to work in this area?
Great question. Thank you very much. There are a couple of things going on here. You're quite right to point this out. Why now? Actually, what happened is that there were some very substantial changes to how legal services could be provided, at least in the United Kingdom, but I believe elsewhere is what happened. So in the United Kingdom, they changed the law about who can provide a legal service. And they did this some years ago. And there was a great effort from the top down, from government, in changing the legislation about who's licensed to serve legal advice. This happened several years ago. And this is really one of the key factors, at least in the United Kingdom, but I believe elsewhere, that unlocked the interest, because suddenly you didn't have to go to law school to provide a legal service. And so that was one factor. So a lot, people came on board and said, oh, well, I'm a computer scientist. I know how to process text. I'm just going to do stuff, right? I think that the deep learning models, had a great impact in stirring excitement. I'm going to make a comment about this that I think will be controversial, maybe, but I'll leave it for a moment. So that was another aspect, is that people could process legal texts. I think what's also happened is that there has been a renewed interest in the last maybe 5 years, intensification in language processing per se, right? I mean, neural nets apply to vision and object recognition, and, music and all sorts of topics, right? Because it's a pattern recognition device in a way. But people started to really focus a lot of attention on language processing and making progress about that. Also, there were another factor that happened, which is rather external, was that there were some crises in the legal industry. If you remember, in I think 2008, there were financial collapses and things like that hit the legal services industry very hard. A lot of lawyers got fired. And the consequence of that is that the law firms were looking for new models to boost their efficiency and basically boost their bottom line with less staff. And the people who went out of work started to look around for new models for how to make money. So I think that there were a variety of vectors that contributed to the development of the last several years that are continuing to develop. Now, I do want to make a remark that not everybody will like, but I'm hoping that I have enough positive asset in this community to make it. Machine learning is not the only way to go, especially about legal information, okay? And it's very important in this context to have a very clear understanding about what's the material, what's the use case, what kind of results do you really want, what kinds of users are you really providing for. Classification is not the only task, especially in the legal context. Reasoning about the law in detail is paramount, okay? And it's very difficult, at least for the bit of machine learning that I understand, it's very difficult to see how we can get the kind of detailed linguistic knowledge that we need to create the kind of reasoning rules that we need in order to draw the inferences that are in demand by this particular market. So I have no doubt that machine learning has many, many application domains, but I also think that the good old knowledge representation and reasoning community has a very big role. And my view would be that some collaboration, greater collaboration across those points of view and across those communities is really going to be called for in making further progress. But thank you for that question.
Thank you. It covered most of my questions. I do have one follow-up question.
Okay.
It's kind of, you mentioned that this change is being driven by the fact that UK now allows legal services to be provided by other companies. Does this mean that there is a chance the lawyers see this as a threat that they might be replaced someday? Of course, I mean, I'm not claiming that it's happening anytime soon.
No, we're not claiming anything like that.
But what's their opinion on this? Because in India, especially, we see a lot of resistance, or at least they are not very keen to use this if it's not that it doesn't perform that well. But there's also this doubt somewhere that what if it replaces us, at least for the menial tasks, not the more complicated cases, but something which is more generic. So is that happening elsewhere as well? Because in UK, if legal services are now allowed by a non-lawyer, then that might be problematic for the legal community, right?
You are absolutely right. There is, I think, a great deal of anxiety. And in fact, the job that I have in Swansea is entirely predicated on the anxiety about, it's not, let's be clear here, it's not about replacing the lawyers, but that the traditional training practice and the traditional practice of lawyers as it's been known for maybe 50, 60, 70 years, that specific training and that specific practice is becoming obsolete. Okay, so it's not that not that the field will be obsolete, but their known practice and known education is obsolete. So what Swansea did, and somebody's going to do this in India, I'm sure. Or by the way, you can send over students from India to Swansea, and we're happy to engage with people, PhD students, master's students, stuff like that. But anyway, I was hired at Swansea because they were concerned about legal tech, and they felt that they needed to start a master's program in legal tech so that law school students would start to get their hands on the tools and techniques of computer science to some degree or another, okay? And that's what we're training people here at Swansea to do. So we only have a small group of students who are really interested in this. By and large, most law school students go for the traditional practice. By and large, law firms are continuing with their practice. Larger law firms or new law firms are focusing more and more on technology. The legal informatics providers, the Thomson Reuters companies and Bloomberg and such like that, are investing very heavily in automation, right? Machine learning, AI tools to help them process their legal materials. So there is a great deal of change. The response to law faculty and law school students is that they can be as conservative as they like. Change is certainly happening, and it's going to be accelerated. Results are not perfect now, and they're far off from being wonderful, but we are engineers, right? We start off with big problems, we decompose it into smaller sub-problems, we work at it until we get high quality solutions, and we're constantly improving things. And if it takes 5 or 10 years or 50 years or 100 years Fine, that's exactly what will happen. But change is certainly happening now. And this is all part of that process. So should they be concerned? No, they shouldn't be concerned, because they should just get on with trying to learn some things about these techniques. By the way, let me just add that the lawyers and the law faculty are absolutely key in making progress, because they have the depth of knowledge and expertise about the law that needs to be brought into machine learning context or knowledge representation and reasoning context. It's not that we're making up the law. We are trying to incorporate all of that legal knowledge into our systems. We did this in our study by saying, we want these annotation types. How do we identify them? Unless you're a lawyer and trained in working with this material, you wouldn't have a clue, okay? So it is a partnership.
Right. Thank you for the comprehensive answer. It was wonderful talk.
Thank you very much. I appreciated having the opportunity.
Yeah, Adam, hello.
Hi.
Hi. So.
There you are. Hey, great to see you.
Yeah. So thank you. Thank you for the wonderful talk. And I just want to make, two corrections. First is firstly, I am, no longer, in an industry. So I have joined, academics very recently.
Sorry, old slide. I had an old slide. My mistake. Sorry.
And secondly, you told that there are not many startups or in law in India. That is, beginning to change. Like in the chat, I pasted the name of one of them. Lonix.com is one of them. And there are many such startups who are interested in doing some progress, which involves basically the partnership which brings the legal community and the artificial intelligence community together. So that is starting in India. That has already started in India. And one passing remark, that you talked about this paper, right? I am fortunate to be a part of this paper, and we are using the data set that was released as a part of the paper in one of the tracks in FIRE this year as a track. So that is basically a data challenge, and we have a lot of participation from all over the world. People are really interested about that piece of work. And sorry we kept you waiting for about 10 minutes, so you joined earlier.
No, I was fine with me. Thank you very much for those comments. Sorry about the reference to the job. Also, and I did mention the track, which I think is fantastic. There are now several at different conferences around the world. There are these legal informatics tracks, and there are lots of opportunities for collaborations that it opens up. I need to work more to contribute to the tracks. That's what I need to do with you.
Sure.
I've put into the chat, by the way, 2 links. One is to UREX and the other one is to ICAL. The International Conference on AI and Law Conference, I think papers are due early February. So there's still some time to pull things together, but something to keep track of. We're probably going to do something online with Zoom or with something else, which means that people who are in India who are not going to travel to Brazil could still participate. I think it's a wonderful opportunity to open this up. Thank you. Thank you so much for working with you. It's been great.
Thank you very much. Same here.
Are there any more questions from the audience? All right. Thank you, Professor Weiner, for being here and giving your talk.
Great,
it was
thank
a
you.
pleasure. Yep. Okay. Thank you. We now move ahead with the presentations. There was with the HASOC Dravidian track. So I hand over to Premjit now. You may take over.
Thank you. So we will continue the second session of HASOC. In this session, we have 3 papers. Okay, before starting the presentation, I have a few requests to make. I request the presenters to share their slides in the chat. And due to the want of time, I request presenters to skip the dataset description slides during the presentation. Okay, so we'll start the presentation. So our first presenter is Ms. Veena PV. She will be presenting her paper, Offensive Language Identification on Code Mixed Social Media Comments. Veena, you can start the presentation.
Okay, so thank you, Prentice. Is my screen visible to all?
Yes, can you please make it okay? Full screen.
Yeah, okay. So hello all, good evening all. Myself Veena, and I'm presenting on behalf of my team, 10 mates, which also consists of Praveena and Renia. And this is just the outline of the presentation. And since the task description was already mentioned, I will just skip the part and I'll just say like this was the code mix data, the aim was to classify it as offensive and non-offensive data. And since hate and offensive classification is an active research area, many works are going on for identifying them effectively. And these are some of the papers which we identified, which uses like ML and machine learning and deep learning approaches. And in our task also, we have proposed like 4 systems, which is logistic regression based, extreme gradient based, and LSTM networks, and finally attention plus LSTM networks. And since the data was a bit noisy, we have performed pre-processing tasks. And also for the LR and HD boost, we have given TF IDF as a vectors. And I'll be explaining each one further in the following slides. So for the pre-processing part, we have just done tokenization, lowercase conversion, and removal of the punctuation, special characters, and also the removal of the emojis. And moving on, for the LR logistic regression and extreme gradient boosting, we have given TF IDF vectors as the features. So TF IDF together represents like how relevant the word is. And for the input to the TF IDF model, we have given character level n-gram, with n-gram ranging from 3 to 5. So I have just given a small example like 3 gram, 4 gram, and 5 gram. And for the methods, we have used like sklearn TF IDF vectorizer, and the maximum features was limited to just 8,000 instead of using the whole vocabulary. And the first system was logistic regression based system, and it's a probabilistic model, and it gives a value between 0 and 1. And since the data was highly imbalanced, we have given class weight as balanced also. And this logistic regression was one of the systems for all the 3 tasks performed. And moving on, second system was the extreme gradient boosting system, and we have used the same TF IDF vectors, character level n-gram features for this XG boost model also. And this was used for task 2, Monglish and English categories. And the third system was LSTM based networks, and we have used a simple LSTM, as you can see in the bottom. So which consists of the Keras embedding layer with the 64-dimension vectors, the second with the LSTM layer with the 50 hidden neurons, the third dense layer with the ReLU as activation and just 32 neurons, and final dense layer with activation layer. And other hyperparameters was like batch size was 32 and number of epochs was 10. And since it was just a binary classification, we used binary cross entropy and Adam as the optimizer. And the final system was attention with LSTM networks, and we have used the model architecture is given below. We have used the same Keras embedding layer and followed by a bidirectional LSTM layers, and then attention network, and followed by 2 dense layers, one with the ReLU activation and one with the sigmoid activation. And these are some of the results. So for task 1, we have used logistic regression and LSTM based network, and these results are just for the validation accuracy. Since we didn't get the gold data set, we thought of showing the results on validation accuracy. And these are the results for the task 2 Monglish data set. So we used logistic regression XG boost and the LSTM based networks. So maybe because the data was less and we didn't use additional data, we could see that the machine learning model was working better than the deep learning models. And for task 2, tongue dish also we used logistic regression, XGBoost, and attention based network. So you can see like attention based network gives less accuracy than the compared with the machine learning models. And these are the results we obtained. Like we got rank 3 for the task 1, rank 1 for the task 2 Mongoose, and rank 4 for the task 2 Tungish. And for like as a conclusion, the same point, since the data was less, we could see that machine learning classifiers produce better results sometimes than the deep learning classifiers. And as future work, we were planning to use like more additional data and maybe like different embedding approaches like a BERT or FastText, and also advanced models like transformers can be experimented. And these are some of the references we saw, and then that's, thank you. Any questions?
Thank you, Veena. Thank you for the presentation. So because of the time constraint, we are moving on to the next presenter. So our next presenter is Ms. Sarah Ranjit. She'll be presenting her paper, Identifying Offensive Language from Monglish Tweets. Veena, you can stop sharing the screen.
Hello, am I audible?
Yes, yes.
Okay. Is my screen visible?
Yes, it is visible.
Good evening all. I'm Sarah Ranjit. I'm from Department of Computer Science QSAT. I'm a research scholar. And this is as part of our work, which was submitted in HAZOC Subtract in FIRE 2020, Identifying Offensive Language from Monglish Tweets. So basically, nowadays we have different platforms for communication like Facebook, etc. And there are advanced technologies which have given the users with a convenience to express their content, their emotions, everything, mostly in of not offensive manner, but sometimes offensive. So here the Subtract in HAZOC FIRE 2020 is aimed in identifying this offensive content from tweets and comments in Monglish and code mix data. It is basically a form of message classification. I'm skipping the task description as well as the dataset part. Coming on to the methodology, we mainly participated in task 2, that is the message level classification of Twitter comments, and that too in Malayalam, which was written using the Roman characters. So coming to the methodology part, our system design is basically shown here, that is using a pre-processing module, which is followed by a common representation module and then a classification. So here we have used the basic pre-processing techniques which are used for tweets, that is removing of stop words, URLs, user names with prefix, @ hash and hashtags, etc. And also we lowercase all the text, and tokenization was also done. And this is done using a tweet preprocessor, which was a library available. Then the next module is a common representation. So we basically thought of representing this Monglish tweets in some form, then passing on to a machine learning module. So first we thought of using a Keras embedding representation, for which we used a one-hot representation of sentences that is fed to a Keras embedding layer in order to produce a 50-dimensional sentence representation. And the other common representation we have used is using a paragraph vector, that is doc-to-vec model, which is an unsupervised algorithm based on word-to-vec. And this was also this was done using the Jensen library doc-to-vec function. And then we did a classification, which is basically a binary classification into offensive and not offensive class. So the first system we tried out was having a pre-processing module. The common representation was done using the Keras embedding layer and followed by an LSTM layer with recurrent dropout. And this was trained for about 5 epochs. The second system also followed the same pre-processing module. Then the difference was with the common representation, that is using the paragraph vector, and which is followed by a multi-layer perceptron with 3 dense layers having ReLU activation, and that was also trained for 50 epochs. The final layer for both the systems is a dense layer with sigmoid activation, binary cross entropy. And the third system we tried out was a logic-based combination of the predictions from the system A and system B. That is, if both the systems predicted the same output, we use the same output for the third system as well. But if the prediction, in the other case, if two systems, the predictions of two systems differ, in that case we take the probability summation of the probabilities from the two system, and if it is greater than 1, we give an offensive label to the predictions of the third system, and otherwise it is not offensive. So the system has been evaluated based on the weighted average precision, recall, and F1 score, and we could see that the results are actually about 0.5, that is only an average performance, and this could be what we have thought was maybe it could be because of the lack of data, which lack of the size in data set size, which could be a reason for this poor performance for the doc2vec or the Keras embedding layer. So coming to the conclusion part, our method used Keras embedding and paragraph vector to form the sentence representation that encode monk-list tweets. We basically focused on how to represent these monk-list tweets before passing on to some machine learning module. Then a simple LSTM and as well as an MLP based classifier is used here. Embedding of monk-list text without losing much information is a challenging part, and the evaluation results also shows that there is a scope for improvement using some pre-trained models like BERT or using other representations. And these are few references, and I would like to thank the FIRE coordinators as well as the HAZOC coordinators for this opportunity. Thank you. Any questions?
Thank you, Sarah, for the presentation.
Thank you.
Okay, so we are moving on to the next presenter. Sarah, you can stop sharing the screen.
Okay.
Thank you. So our next presenter is Mr. Prasad Joshi. He'll be presenting his paper using machine learning for detection of hate speech and offensive code-mixed social media text. So I welcome Prasad Joshi to present his paper.
Hello, am I audible?
Yes, yes.
Yes, okay. Due to the time constraint, I'm just keeping the data set related details on the behalf of KBC North Maharashtra University, Jalgaon, Maharashtra, and my teammates Varsha Pathak Madam, Manish Joshi Sir, Monika Mundana Madam, and Tanmay. Myself, Prasad Joshi, I'm going to present the going to conduct the today's presentation. The table of the contents are going to distributed into the 5 sections. I'm not going to talk much about the data set because it has been discussed previously by the teammates and the presenters. For the feature extraction, first of all, we have pre-processed the data and we have removed the emojis, stop words, special characters, digits, and special tags like retweet tag and the user. And for extracting the features, we have used the TF-IDF. The TF-IDF gives the weightage to the word which is being relevant to the document or relevant to the tweet. And the second feature extraction that we have used is the word embedding. Here we have used custom word embedding, though there are different word embedding like word2vec, fire, fasttext, glow, but we have use the custom word embedding. After extracting the features from TF-IDF, we have used the traditional machine learning classifier like SVC, MNB, LR, DTC, RFC, and the ensemble approach. In ensemble approach, we have used the best performing classifiers like SVC, MNB, and LR. And after extracting the word, extracting the features from customer word embedding, we have created a simple neural network model. Here is just an presentation that how the two different feature extractor has been applied. For TF IDF, we have applied the three different variations of it: character engram, word engram, and combined character and word engram. For character engram, in case of Malayalam language, we have the engram range of 1 to 5. And for in case of Tamil, we have used the 1 to 7. And for word engram, we have applied the engram range of 1 to 2. And for Tamil, we have applied the engram range of 1 to 4. And for combine, the combination of both of this character and word engram. We have not restricted any features so that the quantity is quite a big. Like for Malayalam, we have extracted the 38,536 character engram, and for the word engram and combined character word engram for Malayalam and Tamil are mentioned over here. Same as that for custom word embedding for both the languages or for both the data sets, we have applied the same techniques. That first of all, we have extracted the unique words from both of the languages, and then using the Keras embedding layer, we have find out the 200 dimensional vector of each extracted word over there. Okay, so that we got the 30 lakhs, near about 30 lakhs to 30 lakh 90,000 Malayalam trainable parameter for the embedding layer, and for Tamil we got 30 lakh 60,000. After extracting this one, first of all, we have implemented the different classifiers on the TF-IDF extracted feature. Here I have listed the different classifier list: SVC, MNB, LR, RFC, DTC, and we have tried to find out the best parameters for both the languages, for Malayalam also and for the Tamil also. These are some of the best parameters for each of the, as you can see, for each of the classifiers. But for neural network that we have implemented on the custom word embedding, we have just stick with the activation function sigmoid and optimizer Adam loss function is binary cross entropy for both the languages, for Malayalam and for Tamil. This is what we can say an architectural view that we have processed the data and split the data into 70 and 30% so as to eliminate the bias while training the data. Next, we have applied the TF-IDF and feature extraction of custom word embedding. After TF-IDF, as I have already discussed, that different classifiers have been implemented, and here the neural network, simple neural network is being implemented, and thus we find out the best performing classifier. This is what the result is in the form of chart, where you can easily see that the MNB of combined word and gram is got the near about 76% of the accuracy. On the y-axis you can see the accuracy, and on the x-axis you can see the different classifiers over there along with the different extracted features. I have not mentioned here the custom word embedding. You can see that the combined word engram and combined character and word engram are for SVC, SVC, LR and ensemble are having the very good results, but the RFC is not performing well for all the three TF-IDF features. And as you can see in the confusion matrix, the prediction of not offensive and offensive tweets for Malayalam language are quite a bit very good. Means if you are going to compare that for ensemble approach, you can see the 518, 530, 517 not offensive tweets are very good. But ensemble approach is not able to predict the offensive tweets, so that we got the means we give this particular accuracy results to the competition. Likewise, for Tamil language, you can see in the chart the SVC for the character engram of range 1 to 7 is getting the 87 or 86 near about accuracy, and you can see here the predictions of means not offensive and offensive tweets are quite very good as compared to the others. The NN model is not performing very good in both in Tamil and Malayalam language, and the accuracy is near about 50%. That is quite a bit surprising. And here we can see that RFC for Tamil is also not performing very well as compared to the other classifiers. At last, when we at the time of conclusion, the features like n-gram, word n-gram, character n-gram, and combined with word and character n-gram and custom word embedding were being applied, and we apply the traditional supervised machine learning approach, and the simple neural network model is being applied on the custom word embedding. We got the F1 score of 77 for Malayalam, and we received the second rank. And for Tamil, we got the 87% accuracy, and received the third rank. Further, we will like to develop a system which will also which will also find out the offensive content from the speech, irrespective of the language also, because this is just the we are finding the offensive content from the text. Also, we would like to find out the false or what we can call it as superficially positive messages that should be found out, because most of the time the messages are superficially positive, but those are in reality those are the negative messages. We would also like to see the language specific features of the Dravidian languages, because we are from the state of Maharashtra, so that we really don't know exactly more detailing about but we would like to find out the language specific features of Dravidian languages. Thank you. This is what all about is.
Thank you, Prasad Joshi. Okay. It's a very good presentation. So with this presentation, we conclude the track presentations of HASOC Dravidian Chord Mix. So I'll take this opportunity to thank everyone for joining the session and participating in the competition and making this competition a great success. Thank you all. I hand over to the coordinators of FIRE for the next session.
Yep. Thank you, Premjit. All right. So given the situation, we have run out of time, unfortunately, for today. And the long paper, the full paper presentations will be shifted to tomorrow. So tomorrow we start at 4:30 p.m. instead of 5 p.m. So from 4:30 to 5 p.m. we will have the full paper presentations. And then, of course, yeah, we have the invited talk for tomorrow by Mr. Ajit Balakrishnan, who is the CEO of Rediff.com. So he will be there. So see you tomorrow. And the invitees of the steering committee meeting, please proceed to use the next link that has been sent to you in an email. Thank you. See you tomorrow.